Good morning, everyone. So at this time, we'll tackle about finding the exact value of the six trigonometric function. Okay, what are these six trigonometric function? We have here sine theta, cosine theta, secant theta, cosecant theta, tangent theta, and cotangent theta. So we have here six trigonometric function. So actually, the process of identifying the exact value of the six trigonometric function is that actually we can make use of the concept of the unit circle. As long as we will be using also the properties of the two special triangles, the 30, 60, 90 and the 45, 45, 90 degrees triangle. So the two types of triangles. The first one is the escalene triangle or the 30, 60, 90 degrees triangle. The second one is the isosceles triangle, the 45, 45, 90 degrees triangle. So the unit circle and those two special triangle can be applied identifying the exact value. So let us, before we could have to identify this, the six trigonometric function, given that the angle theta is 120 degrees and 150, let us tackle first about what are those special triangle, okay, and its measurement of its side. Okay, we have here the first triangle, the 45, 45. Okay. The 45 degrees triangle, 90 degrees. So actually, this one is what we call as the isosceles triangle. There is actually a measure for each side. The opposite for 45 degrees is 1 unit. This one also is 1 unit. And opposite to the angle of the side opposite to 90 degrees is actually having a square root of 2 units. This one is the isosceles triangle. We have 45, 45, and 90. Wherein the opposite to 45, the side opposite to 45 has a measure of 1 unit. We have also here 1 unit. It is called as isosceles because the two sides are equal and the two angles also are equal or congruent. Okay, let us have now the second type of triangle, the 30, 60, 90 degree triangle. Okay, the 30, 60. So this one is the 60 degrees, this one is the 30 degrees, and this one is the 90 degrees. According to the theorem that the side opposite to 30 degrees is 1, okay, 1 unit. Okay, 1 unit. And the side opposite to 60 degrees is square root of 3 units. And the side opposite to the 90 degrees is we have here 2. Okay, that was according to the theorem. But of course, since this one or these two triangles are right triangles, therefore we can actually apply the Pythagorean theorem to verify if the given measurement is really accurate. But of course, this one with this squared, this is actually 2, and 1 squared is 1. Then if you're going to add 1 squared and 1 squared in here, that is equivalent to 2. So therefore, it will also, or we could also verify that one using the Pythagorean theorem. The c squared is equal to a squared plus b squared formula. So now, we can now find the exact value, or we can now identify the exact value using the angle theta, which is 120 degrees and 150 degrees. But of course, those measurements will be used along the way as we figure out this one using the concept of the unit circle. Okay? Of course, we will have to draw also 120 degrees in the rectangular coordinate plane, considering that in every quadrant, there must be sign that we are going to follow. For quadrant 1, the sign will be all positive. And for quadrant 2, the sign will be negative and positive. And for quadrant 3, they are all positive, negative rather. And for quadrant 4, we have positive and negative. So let us have this one. Okay, first we are given the angle theta. Okay, the angle theta, we have 120. The first is 120 degrees. Okay. Then we can now draw rectangular coordinate plane for that one, 120 degrees. Okay, 120. So of course, this one is our initial side, padulungan to is our terminal side. From this one, we know that that one is 90 degrees. because this side y and x are perpendicular. So this is 90 degrees. So how much we are going to proceed so that we can obtain 120 degrees? We are given only 90. So the lucky now is, or what we're going to do is we will have to add now 30 degrees so that we can obtain 120 degrees. Okay? So we have here 30 degrees. This one is 30 degrees. This one is 60, or this angle is 60 degrees. This angle is 30 degrees, and this angle is 90 degrees. So we are now in quadrant 2. Okay? 90 and 30. Sir, bakit pwede sa triangle ng anak? Dili siya actually pwede because in rectangular coordinate plane, particularly in using a trigonometric measure, there must be no triangle wherein inverted. No? Meaning, wala triangle na magbalik or magkuwad. No? So it must be one of the leg must be perpendicular to the x-axis, which is this leg or this one parallel to the y-axis, perpendicular to the x-axis. We have here 90. Accordingly, this side opposite to 30 is 1. But remember, we are now in quadrant 2, so therefore this is negative. Okay, negative 1. And the side opposite to 60 degrees is the square root of 3. And still that is positive because that is parallel to y, therefore this one is also y, and at the same time that is also positive because in y direction that is positive. And of course the hypotenuse or the side, the longest side opposite to 90 degrees is, it should be always positive and it has a square root of 2. Then we can now identify the 6th trigonometric value of the trigonometric function. Now first we have here f of theta is equal to sine theta, provided that our theta in here is equal to 120 degrees. So f of 120 degrees is equivalent to sine of what? 120 degrees. Using the concept of sine and cosine, we know that sine theta is equal to opposite. So opposite over, okay, opposite over hypotenuse. Okay, hypotenuse. Another one, we know also that cos theta is equivalent to adjacent over hypotenuse. Okay, adjacent over hypotenuse. Next, we also have tan theta. Tan theta is equal to opposite over, okay, opposite over adjacent. Okay. Then for the inverse of this one is what we call as cosecant. Okay, cosecant theta is equal to hypotenuse over opposite. Okay, and in here the opposite for cosine is secant. Okay, we have secant theta is equivalent to opposite. Okay, the secant theta is equal to hypotenuse over adjacent. Next, we also have here the opposite for or the inverse of tangent is cotangent theta, and that is, this is tan to this is cow, no? Adjacent over opposite. So these are the concepts that we'll be using for identifying exact value. First, we have here sine of 120 degrees. So sine of 120 degrees. So again, direct base ng angle. This will be our hypotenuse, this will be our opposite side, and this will be our adjacent. Again, this side is the hypotenuse. This side having the square root of 3 as measurement is the opposite. And this side, we have negative 1 as our adjacent. So therefore, sine theta or sine of 120 is so opposite, diba? Opposite over hypotenuse. Opposite over hypotenuse is we have square root of 3 over 2. Okay, that is for sine theta. Okay, what about for cos theta? Okay, we We have here cos theta, f of theta is equal to cos theta. Provided that cos theta or theta is equal to 120 degrees. So that is just equivalent to 1. How much will be, or what will be the answer for cos of 120? Cos. Remember, cos is adjacent over hypotenuse. So cos of 120 adjacent over hypotenuse is equal to negative 1/2. Okay, negative 1/2. Next, we also have here tangent. No? Tan theta or f of theta is equal to tan theta, or that is tan of 120 degrees. So, di naman answer sa tan of 120. Tan of 120 is 2, opposite over adjacent. So, opposite over adjacent is square root of 3. Square root of 3 over 2, opposite over adjacent is negative 1. Okay? And that is equal to negative square root of 3. Okay, what about now the remaining 3? No? The opposite to this one. So we also have here, next is f of theta is equal to cosecant theta, and that is equal to cosecant of 120 degrees. Actually, they are just opposite, no? So let us prove. Cosecant, no? Hypotenuse over opposite. Hypotenuse over opposite, so we have 2 over square root of 3, because that is hypotenuse over opposite. So 2 over square root of 3. By rationalizing, that is just equal to 2 over square root of 3 times square root of 3 over square root of 3. Why we do this? Because actually 2 over square root of 3, we must still have to simplify that one so that the denominator part, there will be no, or the quantity in the denominator part, it must not be what? Expressed in radical form. No? So let us simplify this one. So 2 times square root of 3 is 2 times square root of 3. Square root of 3 times square root of 3 is square root of 3 to the power of 2, and that is equal to 2 times square root of 3 over 3. Okay? So we have here 2 times square root of 3 over 3 as the answer for cosecant theta. Okay, let us proceed now. Okay, let us proceed now. Let us use this space now for cos theta. Next, we have here f of theta is equal to cos theta. So, kailangan si cos theta. Theta is, we have here 120 degrees. Cos of 120. Okay, we are actually done of cos. The opposite of cos pala. No? The opposite for cos is we have secant. No? Secant theta, or secant of 120 degrees. Sorry. So, secant theta is actually hypotenuse over adjacent. Okay, we have hypotenuse over adjacent. We have 2 over negative 1. The answer is negative 2. Okay? Next, we have f of theta is equal to 1. The next one, cotangent theta. Okay? For cotangent theta, or cot of 120 degrees. Hindi naman, ikaw, cot. Adjacent over opposite. So we have adjacent over opposite, negative 1 over square root of 3. By rationalizing, that is just actually equivalent to negative square root of 3 over 3. Okay? So I hope that this one actually will help you in answering your problems, particularly in identifying the exact value or the exact value of the 6th trigonometric function given the degrees measure or maybe in the radian measure. If the angle theta given is expressed in radian measure, of course, you still have to convert that one into degrees measure. Then use this concept using the unit circle and the special triangle, the isosceles and scalene triangle.